All right, so limiting reagents. What are they? What can they do? Where do we get them from? Why do we actually have them? All right, so with the limiting reagents, it is um, every time that we always. Sorry, just getting. So anytime that we have a reaction taking place, we've got two things at least. So in the reaction, reaction, and they have to have a fixed ratio in which they can combine together. Using our standard one that we always use, we've got water. Actually, let's just use sodium chloride today. We've got sodium and you've got chloride. So there you've got a 1-to-1 ratio between both of your compounds. So sodium plus chloride, sodium chloride, and you make 1 mole of that. 1 mole of that, 1 mole of that, which equals 1 mole of this. When we have a limiting reagent, it means that we have less of something, which means that we can't make the entire thing. Normally, when we do reactions at school, or even when we do a general reaction, we want to use up all of one thing, which means that we have an excess of the other one. So, if I had 1 mole of sodium, which is the harder thing to get in this example, but I have unlimited Cl, this will be my limiting reagent. Limiting reagent. Reason for that is I have only a certain amount of that stuff, heaps of this. So lots of this. So in that case, my sodium is my limiting reagent, and I would only ever be able to make 1 mole of sodium chloride in the end. If we move on, let's have a look at this example. Water, the reaction for that is 2H2, and that's going to be a liquid. Oh, it's going to be in a gas, plus O2, also in a gas, because that's how we find it in the atmosphere. It's going to make 2H2O. It's going to form it as a steam because it's a quick reaction. So we're going to have water as a gas. So we've got 2 mole of hydrogen reacting with 1 mole of oxygen to form 2 mole of water. So in this situation, that we can find out which one our limiting reagent will be by how much stuff we have or where we're actually getting it from. Let's go through and have a look at how much mass our. Actually, let's go through and just break it down. So, let's go Harry, because we don't have a Harry in our class. Has 1 mole of hydrogen gas, but is thirsty and wants to drink water. Will the hydrogen or oxygen in the atmosphere be the limiting reagent? So in that example there, we know that Harry only has 1 mole of hydrogen gas, therefore he can only produce a certain amount of water from that because he has unlimited oxygen because it's essentially in the atmosphere. So he's got the entire world's oxygen supply. So in this case, hydrogen is the limiting reagent. If we break this down and we go a bit further with it, we can go through and we can figure out how much stuff they've actually got. So we'll go next question. Harry doesn't know how many mole of oxygen or hydrogen he has in a closed container, but he does know their mass. H2 mass, it's going to go, let's say he has, let's go 6 grams of hydrogen gas and of oxygen gas. How much can he have? Let's go 40 grams. So he's got 6 grams of hydrogen gas and he's got 40 grams of oxygen gas. So because of these, we're looking at them in like the polyatomic one. So we've got the actual molecular compound. When we do our molar mass and our molar calculations, we're going to have to keep it as a 2. So it's going to have to be double the original mass. So let's figure out what our hydrogen original mass is. So first, molar mass of H2 equals 1.008 times 2, because we got the 2 atoms, which gives us 2.016 grams per mole. For the oxygen, molar mass of oxygen equals 16 times 2, which equals 32 grams per mole. So we've got that first initial part ready. Now let's figure out how many moles we've got in total for our original mass. So we use that one again from last period. So you go N equals mass divided by mole mass. So for hydrogen, we've got 6 divided by 2.016, which gives us 2.98 mole. And for oxygen, we have 40 divided by 32, which equals which equals 1.25 mole in total. So from here, we know that we have a ratio between, and then let's write down the equation again. So you're going to have, for making oxygen, you have 2 H2 in gas form plus O2, it's going to form 2 H2O also in gas. So we write down these numbers. So we've got 2.98 plus 1.25 to go to form however many. This isn't a straight 1-to-1 ratio though. So in this case, alright, so from here, I need 2 of these to 1 of these, which means I have to double the amount of that one. So if I times that by 2, it tells me that I have less than double, because double that one actually gives me 2.5. That has 2.98. So I'm going to have a leftover of 0.48 at the end. This is my leftover. So that means that my maximum number of water that I can make will actually end up being 2.5 mole of H2O. So from that one, we can see that our oxygen is our limiting factor. So we don't have enough oxygen to be able to make the full amount of H2O that as I have from the amount of hydrogen that I've been given in the first place. So that is generally limiting factors. And that would be how much our leftover is.